Alright, we're going to look at some problems in Chapter 15, Coordinate Geometry, also known as Analytic Geometry. We're going to begin by looking at an example, taking a couple of points. Point P, coordinates 3, 9, point Q, coordinates -2, 4. We're going to do three things. We're going to find the distance from P to Q, or in the text, length PQ, no symbol above it, that means a distance. We're going to find the midpoint of segment PQ, and we're going to find the slope of line PQ. So, for part A, the distance formula, square root of this quantity, we subtract the x coordinates, x2 minus x1 squared, then we add the difference of the y coordinates, y2 minus y1 squared. As you know, this comes from the Pythagorean theorem. But anyway, we plug in the coordinates. Which one you decide is x1, y1 doesn't really make a difference. 3 minus -2, that's plus 2 squared. 9 minus 4 squared, 5 squared plus 5 squared, and 5 squared is 25, so this is the square root of 50. We can write it as a simplified radical, 5 times the square root of 2, or if you needed a decimal, it would be about 7.07. So that's the distance. Part B, we want to find the midpoint of segment PQ. Very simply, take the two x coordinates and average them. Add them together. 3 plus -2 over 1. That's, over 2, the average of them, over 2, and that is 1/2. Take the two y coordinates and do the same thing. So the y coordinate for the midpoint, 9 plus 4 over 2, and that's 13 over 2, which is 6.5. So the midpoint coordinates are 1/2, 6 and 1/2. Part C, the slope. We're going to subtract the y coordinates first, and that goes in the numerator. 9 minus 4 on top. X coordinates, same direction. 3 minus -2, which is plus 2 on the bottom. That's 5 over 5, which is 1. So the slope of line PQ is 1. Alright. For the next few examples, we're going to go to some problems in the textbook. We're going to go to page 817. We're going to start with problem 8B. Now we're given 4 points with their coordinates. A is at 0, 4, B is at 6, 8, P is -4, -6, and Q is at 2, -2. And what we want to do is determine whether segment AB is parallel to segment PQ. What we'll do is determine the slopes of those two segments. The slope of AB, subtract the y coordinates, 8 minus 4, x coordinates, 6 minus 0, that's 4 over 6, and I'm going to reduce that to 2/3. Find the slope of segment PQ. Again, subtract the y coordinates on top. -2 plus 6 on the bottom. 2 plus 4. It's always minus, but minus a negative. And that's 4 over 6, and that's 2/3. Now you notice that we got the same slope, therefore AB is parallel to PQ. Same slopes means they're parallel. Problem 10b, we want to find the slope of a line that's perpendicular to line AB, where point A has coordinates 0, 4, and B is -6, -5. Well, let's find the slope of line AB first. The slope of line AB, -5 minus 4 on top, -6 minus 0 on the bottom. That's -9 over -6. 3/2 is the slope of line AB. Now, in order to find the slope of a line perpendicular, we take the negative of the reciprocal. So the slope of a perpendicular line here would be opposite sign, flip it over, -2/3. We're going to move to section 15.2 to look at some further problems. Page 830 is where the problems begin, and we're going to start with problem 4a. And we have a linear equation, 2y is equal to 6x plus 12, and we want to put it in what is called slope-intercept form. In this particular case, very simply, divide everything by 2 and reduce. We get y is equal to 3x plus 6. That's slope-intercept form. 3 is the slope of the line. 6 is the y-intercept. In problem 5b, we're going in the opposite direction. We're given the slope of the line is -1. The y-intercept, indicated by the letter b, is -3. We want to write the slope-intercept form of the equation of the line. Y equals mx plus b is the formula for slope-intercept form. Now we simply plug in the two numbers. Slope is -1, so -1x, whoops, that should be an x, plus b, -3. You can write it as -x minus 3 in simplest form. Slope is -1 times x, and then add the intercept, slope-intercept form. Problem 9a, we want to write the point-slope form for the equation of the line that goes through the point to -3 and has slope -2. Point-slope form is y minus y1 equals m times x minus x1, where m is the slope and x1, y1 are the coordinates of the given point. Now we simply substitute those three numbers in. So y minus -3, that's a plus 3, is -2 times x minus 2. So here is the equation in what is called point-slope form. Now, you can algebraically transform this into slope-intercept form. Follow these steps. I'm going to distribute the -2, so -2x plus 4, subtract 3 from both sides of the equation, and I get y is equal to -2x plus 1, and now I have slope-intercept form. Same equation, different form. Here's the equation in point-slope form, Here's the same equation in slope-intercept form. Problem 10b, find the equation of the line that goes through the point -1, 0 and is parallel to the given line 3x plus 2y equals 6. Now this equation is in standard form, but we need to find the slope of it. 3x plus 2y equals 6. I want to put it in slope-intercept form. I'm going to subtract 3 over to the other side. 2y is equal to negative 3x plus 6. Divide everything by 2, and I get y is equal to negative 3/2 x plus 3. So the slope of this line is negative 3/2. Now we're looking for a line that's parallel to it. Parallel lines have the same slope. This is our slope. Here's our given point. So y minus y1 is slope times x minus x1. Y minus 0, slope negative 3/2 times x minus the negative 1, that's a plus 1. Now, y minus 0, that's just y. Distribute here, negative 3/2 x minus 3/2. And there's the equation of the line we're looking for, and it's in slope-intercept form. Find an equation for the line that goes through the point 6, 0 and is perpendicular to the given line, y is equal to 2/3 x minus 1. This is problem 11a. Well, the slope of the given line is 2/3. The slope of a line that is perpendicular to it, change the sign, take the reciprocal, negative 3 over 2. Now let's go to point slope form. Y minus y1 is slope times x minus x1. We know we have the point 6, 0, so it's y minus 0 is negative 3/2 times x minus 6. And I want to go to slope-intercept form. Again, y minus 0 is just y, and I need to distribute here, so I have negative 3/2 x plus 18/2, and I can reduce that. So y is negative 3/2 x plus 9. This line is perpendicular to the given line, and it passes through the point 6, 0.